In the previous lecture, we tried to access one of the members inside of the pistons array. We tried to grab one of these objects. Unfortunately, it didn't work. It treated it as a number instead of a symbol link or memory pointer. Now, you have two choices. You can try to access a member by the dot syntax, or you could do it with the computed member access. Now, this operator uses the brackets, and inside of the brackets, it computes and then it delivers the result. So instead of using the dot syntax this time, I want to now change it to the brackets. So you either use the dot or you use the brackets, but you cannot use both. Don't forget, you use either this operator to access a symbol or a member, or you use the brackets to access a member, but you don't use both. So you don't say dot brackets. That's not allowed. You use one operator or the other operator to access a member. So now we're looking inside of the pistons array, and we're grabbing the element with the ID of 0, which is this particular object. So I can go ahead and take a look at this now, and you'll notice it returns that object, make a BMW. Now what happens when I want to actually target this property specifically and just return the string BMW? Which operator should we use? Now don't forget, this is a standard symbol link or memory pointer with the word maker. And what have we been doing prior? Well, we've been using the dot syntax to actually gain access to these members with a simple name. It's only when it turns into a number, this number is computed inside of the brackets, and what's returned is a symbol link instead of a number type. So what I can do now is use the dot syntax again. So we're inside of this object. Then we're saying, right, I want to access a member inside of this object. So we're going to the next member, and that is going to be maker. So now we're going to pull out the string BMW. So you can mix and match. You can either go with the dot syntax, or if you come to, let's say, a key name that is a number, such as an array, then in fact what you want to do is use the brackets. And likewise, we can do the same for the array. Now the array is an array, and each one of these members in our array has a number. So for example, you could pull out the string. This has the index of 0. So I can say array, and in the brackets 0, this will return not a number 0, but a memory pointer 0. And so then we have string. You can even pull out a function, for example. How do we invoke this function right here with this spelling mistake? Is we access it by its number, by its ID. So we've got 0, 1, 2, 3, and 4. So this is actually the key name 4. And then what happens then? Well, if you just run it like so, it just prints out the function. How do we get it to run this execution context? Well, how we get it to run this execution context is you target it, and then you put in the parentheses. And when you put in these parentheses, it tells it to run this execution context. Notice what happens. It runs, and then of course it returns the wrong thing. Let's do that again. Drive. And there we go. It returns the string drive. So this is quite nice. Now you know about mathematical expressions and statements. When we write something out, such as var a equals, and then you put in a value, for example, you can in fact create a statement. That is a statement. It's a command. It's a sentence you're giving to the JIT compiler, and it's executing. And then also you can have mathematical equations such as 1 plus 1 minus 1. And what is that going to equal? That is going to equal 1, or let's say minus 2. So we have all these operators here, the plus and the minus operators. You're going, well, I know that, but this is a statement, and this is also a statement. Now, when you have the computed member access, whatever is inside of the brackets is treated as a JavaScript statement. So for example, what I can do now is I can clear this out. Let's say that I target the array this time, and I'm going to do something a little bit different. Inside of my brackets, I'm actually going to write out a statement. 1 plus 1 minus 2. So whatever is in between these brackets will be executed, will be invoked, and it will return the value 0. So if I go ahead and hit return, you'll notice that it returned 0. This is like saying array returning 0, the number 0, and that will be used as the symbol link. And there it is, string. So you can see that we can write mathematical expressions inside of here and also regular statements as well. Because don't forget, you can actually use variables in your mathematical expressions. So you can create a variable called a and it's equal to 10. We've created this symbol link in memory and it references the number 10. And then you can say a plus 1 minus 5, which will leave us 6. So we add 1, that's 11, take away 5 is 6. Hit return, and there you go. You can use variables in your mathematical expressions, just like you use variables, algebra, in maths. So that we can change this and move things around. So now let's take a and let's use it again. So I'm going to say array, and then we're going to say a. So now we are pointing to this variable that I've created on the window object, and then I can say take away 5 and then take away 2. So if I take away 5, that leaves 5 left, and then we take away 2, that will leave 3. And what is the third member? 0, 1, 2, and 3 is, in fact, our car object. So let's go ahead and hit return, and that's exactly what we get. It's the same as typing array. It computes what's inside of the bracket, so a minus 5 minus 2 is equal to 3, and then it returns that as a symbolic link. It executes that statement. It's computing the statement, whatever is inside of those brackets. And there we go, it's returning this. So if we want to dynamically fetch something out of an object, like writing an expression, we can do this. Now what about, let's say I want to access car and then I want to access the make symbol, but this time I don't want to do it the traditional way, so car.make. Instead I want to use the brackets. Now here's the problem. It's actually going to look for the variable called make, which we haven't made this variable, just like we called the a variable in our mathematical expression. Don't forget, this is treated like JavaScript in between these brackets. It's a statement. So if I was to change this to, let's say, make, you'll get an error because it's looking through the window object, it's looking through the warehouse, the window, and it cannot find a variable called make. But we do have this property here called make. So if I was to say car, and then I was to turn it into a string, now what it will do is it will return this primitive value, it will do the computation, and there's only a string here, and it will turn this string into a memory pointer called make. So you have car make, and then you can see it pulls out Volvo. So please be very careful when you want to access certain properties with the computed property. Treat it like you writing a statement out like that, saying make right here, and you can see, sorry, it's not been defined, just like we got right here. It's like writing it outside of the brackets. So it's computing what's in between there. It's looking for variables and so forth. And you can keep going with this. So you have car, and then you can access the engine object, this object here. And there we go, we have that object, and then you can go ahead and access the pistons as well. So we can say pistons, which is the array, and we have an array of 2 objects. The first one has the index of 0, the other one has the index of 1. So let's go ahead and grab this out. So I'm going to say pistons and then 1. And it will grab this element right here. And then I can even use brackets again and say go grab the maker as well, which stores the string BMW2. So we go to car, then we go to engine, then we go to pistons, then we access the second object in the array with the index of 1, then finally we go inside of the object and we grab out the maker property there, which stores the value BMW2. And you can do lots and lots of powerful things when you use the brackets. And you can still invoke, let's say, subroutines as well. So again, I could say car, and then I can access drive, for example. So now I'm accessing this method, and then what I can do is I can invoke this with the parentheses after it. And there it is. It returns the string drive. Or if I don't put in the parentheses, I can actually see the function syntax itself. So that is the brackets. You use brackets for, let's say, writing statements out. This could be a mathematical expression. You could also target a variable. So I can say var pointer, and pointer could be, let's say, make, for example. And then I can end with a semicolon. And then I can say, right, target car. And then I want you to go grab the variable called pointer and grab its value, which has the string make. So this will return the string make, and that will return Volvo. It's the same as writing car. It executes whatever is inside of the brackets. So the bracket says, right, there's a variable called pointer, and we return that value, which is make. So it's the same as writing make, and then we return it. So there is the value Volvo again. And if I was to change pointer now, pointer is a variable, so I can change its value to, let's say, speed. So pointer is now equal to the string speed. Let's go ahead and say car brackets pointer and hit return. And there we go. Now pointer is returning the string speed. It's returning that in those brackets, that computation. It takes that string and it turns it into a memory pointer. And there it is, 160. So that is why we have the computational brackets. You can also do all kinds of things like concatenation inside of here. So for example, let's say I have car, and then we have en plus gin, like so. What will this do? Well, it will concatenate. The plus operator concatenates, meaning joins together these strings. So it will join together these strings, which will be engine, and it will return that and turn it into a memory pointer. So I can say, like so. So this will be computed, whatever is inside of the brackets, and it will return the string engine, which should return this object. It's the same as writing car and then engine in the brackets. And also what you can have is car.engine. So you have this ability to mix and match between the dot syntax. And if you need a bit of computation in there, such as the elements in an array that is a number, or if you'd like to fetch a key via, let's say, another memory pointer like a variable, then you can do that with these brackets.